Okay, this is TempleOS 5-minute random code walkthrough, episode 31, and I'm your host, Terry Davis. Let's see where God takes us today. Alt-B. And looks like we are in... Oh, okay. Well, this is some scraps of code that I wrote for an IDE, Integrated Development Environment. Let's go ahead and I warn people up front to not use the IDE. Let's see what this does. I'm going to take this code and go to my account and shove it in here. Okay, so I guess we can run it in a problem. Let's Control Shift L, re-indent. Okay, well that didn't do much. Semicolon. Control Shift L, re-indent. Okay, so let's see what when you run the IDE. I got rid of it because it was terrible. The main problem is screen real estate. So TempleOS IDE debugger. Do not use this on files that run when included. Okay, so what that's talking about is you'll notice I have to do main down here. So when you used the old debugger, you used to have to comment out to use, set a breakpoint in the editor, run the program from the command line, then it would step into and out of code. It was not a very friendly program to use, so I got rid of it. I made that choice on the basis of quality control. It was an embarrassment. It wasn't worth it. I do not use this debugger because I am always doing multitasking stuff, kernel stuff, and multi-core stuff. Also, you can't debug code in the window manager callbacks. So when I do graphics, it's done from a different task that does a callback. The window manager does all the graphics with a callback. So debugging is a nightmare. Let's say you put a breakpoint in the window manager, suddenly nothing on the screen would update. So that's not very... So that's a lot of code that you can't debug. If you can't debug the graphics, then what good is the debugger? So I said when I debug, I use progress 1 to 4. Progress 1 to 4 are these... You see these little progress things on the wallpaper? They're just integers, and I put numbers there when I want to display. I use raw print, raw dump, raw. Okay, raw print will bypass the window manager and do a print to the VGA directly. So the window manager runs 30 times a second to update the screen. And sometimes you don't have a window and you just want to update. And so what it does is it prints on the screen, then it locks everything up for... You tell it how many milliseconds you want to lock up, and then raw print. Anyway, beep and sound. I don't have sound on this machine. Atom log, I never use that. I wrote it down, but I never use it. This I used. There's a bit called the debug bit, and I set the bit when I want to start debugging, then I check the bit with is sysdebug. It's just a bit. That's all it is, and it's really handy because when I'm working on the compiler, it's I need it to sometimes be the new version and sometimes be the old version, and so I set the debug bit. I use that a lot. Okay, what was I going to talk about? Let's talk about there's a fault handler. I wouldn't really call it a debugger. It is a debugger, but let's see here. Debug help. That's not going to help. If I enter the debugger, then the frame grabber that's making this video crashes. So let's go to the kernel. I just want to see the help for the debugger. Where's the help? And I was just going to talk about it. Debug help. Didn't I say that? I thought I said that. What is your malfunction? Oh well. Debug help. Maybe it's not externed. That's what it is. I don't know. Wait. There we go. Okay. So this is the debugger help. If you get a black and white screen that it looks like a kernel panic, that's the debugger. You can edit with edlight. That runs in the raw panic mode. You can dump memory. There's two ways of dumping memory. Let's say I dump 0x 10,000. Now if I say dump dm, one gives offsets from anyway. You can put a limit on how much is jumped. Class rep is nice. Like if I say class rep fs is the current task register. So there's in the debugger you can't use dynamic, but at the command line in the non-debugger you can use dynamic class rep, which you can change members of a structure. Like I can change the left coordinate of the window to column 3, and it's live. Anyway, so class rep, what those know the class, the class type. They know this is FS is a C task. FS is a C task structure, and this class rep function knows the type of the class. Caller rep. Okay, caller rep. You can put this in your code. You can use it at the command line. It's the call stack. DA dump address. So in the debugger, you can use underscore in a register name. You can assign to a register with that. It is the well, if you think about it, the debugger has registers, and then the task you're debugging has registers. So this is the task you're debugging, which is whatever the last task was. It's so it's kind of ambiguous, isn't it? Or how do you? It's kind of not. I don't know if the word's ambiguous. It's kind of confusing. How do you know what task? If you change a register, how is it going to do anything? Anyway, so that changes the. Those are aliases for FSRIP. FSRIP is the current task instruction pointer. That's the saved register. Anyway, long story short. So you can declare variables and do calculations. The debugger is the same command line that's normal. It's just black and white, and it doesn't. In the debugger, you don't get active widgets. So the debugger command line, you don't get active widgets. You don't get windows. You don't get multiple windows. You don't get borders, all that. So anyway, unassemble, and if you tell it a value, that's address 10,000. That's down in the kernel. You can unassemble, or you can say unassemble function. How about line rep? How about line rep? So this unassembles with source code debugging. You don't get the links active in the debugger. You don't get active links, so it's a nightmare typing all this stuff. So to edit a file in the debugger, oh, it's a nightmare. Okay, man page. Let's say you want a symbol. I don't know what that does in the debugger. Oh, it edits the source for the symbol. I was wrong. That's how you do it. Okay. So if you want to go jump to a function, you use the man page. Like if I say man line rep, then we're at the line rep. So that works in the debugger too. Edit. Oh, I knew about this. Edit. If you want to edit an address, edit. What's at 10,000? Well, we know ahead that it's line rep at 10,000. No, it's not. What's at 10,000? I forgot. This is what's at 10,000. The compression. Let's unassemble 10,000. We're in the compression arc expand buffer. So you can edit at a fix. Let's say you get a compiler bug, syntax error type fix that'll take you to the spot. You can set a breakpoint, clear all breakpoints, single step. Okay, you can't single step off of or on. I think you have to remove the breakpoint to single step. I don't remember. It's not useful. I don't find any use. Just use Printf Debugging, and pay attention to the call stack when you get a kernel panic. Two things are important. The call stack, when it crashes, you look at the call stack and the RIP. That's useful. And the other thing is use Printf Debugging. If you really want to play with these breakpoints, a breakpoint is associated with a certain task. So let's say your task calls the window manager to paint graphics. If you put a breakpoint in the window manager task, all of them are going to hit it. And anyway, exit the debugger. Okay, this is important. If I get a crash, normally I type exit, and that kills the task, and I can continue working. It's normal to crash and have to reboot in this operating system. That's you don't have protections. It's like a Commodore 64. But if you want to, normally I wouldn't recommend hitting go. Type exit and hit. If you get in a debugger, type exit semicolon. Take note of the call stack report that's shown, and then then type exit. That's what I recommend. And use Printf Debugging, and use that debug flag, and use progress for displaying values. That's what I recommend.